I wanted to do another quick little review on implicits, starting with this kind of simple example, I hope. I'm going to write this, instead of x cubed multiplied by 2 minus x, I'm just going to write 2x cubed minus x to the fourth. So the derivative, we'd have 2y dy dx equals 6x squared minus 4x cubed. Divide both sides by 2y. There's our derivative. So the equation of the tangent line when x is equal to 1. Well, for every tangent line, remember, we need a point and a slope. I'm going to start with the point because I know what x is, but I don't know what y is. So let me, y squared is equal to 2 times 1 cubed minus 1 to the fourth. So y squared is equal to 1. So y is equal to plus or minus 1. And I did include the graph here. You can see when x is 1, we do have two y coordinates. Okay, so we are going to have two tangent lines. So we're going to have the point 1, 1, and we're going to have the point 1, negative 1. So to get the slope, of course, we just have to plug that into the derivative. We end up, of course, having to do it twice. So plugging in, let's start with 1, 1. 6 minus 4 divided by 2 is just 1. And 6 minus 4 divided by negative 2 is negative 1. So my tangent lines are y equals 1 multiplied by x minus 1 plus 1. And this one. So there are the two tangent lines. Now the spot where the tangent line is horizontal. Now remember, horizontal means that the derivative is equal to 0. Vertical would mean the derivative is undefined. So for us, what we really care about is where the numerator is equal to 0. So I could do a little factoring here. Maybe take a 2x. This one right here should be an x squared. Take a 2x squared out, left with 3 minus 2x. So x equals 0, and x equals 3 halves. If I wanted to get the y coordinates, of course, I could just go right back up to the original, plug those in, and solve for y. Of course, if I plug in 0, 0 minus 0 is 0. So there's their horizontal right there, 0, 0. If I plugged in 3 halves, I'd end up with a number equals y squared, so I'd have a plus or minus. So you can see here 3 halves, there's the positive, 3 halves, there's the negative. Okay? Okay, here's another example. Let's start by finding the derivative. I'm going to maybe skip some steps just in the interest of space, and I think that you have seen this enough already. Don't forget your product rule. Okay, we get our dy dx stuff together and then factor it out. Get the other stuff on the other side. Divide. Here's our derivative. Okay, now finding the equation, the tangent line at the point 3, 3. Here you can see the point on the graph, 3, 3 is right there. So we have the point. Okay, we need the slope. Of course, we do that by plugging 3, 3 in. So 6 times 3 minus 3 times 3 squared. So we have 18 minus 27. So the top is negative 9. Bottom, 3 times 3 squared minus 6 times 3, so 27 minus 18 is positive 9. So our slope is negative 1. So there's our tangent line. Now, find any spots where the equation of the tangent line is horizontal. Okay, we can definitely see some. right? There's one here. There's another one up here. So again, we want to make sure that we're setting the top equal to 0. 6y minus 3x squared needs to be 0, which means that 6y needs to be 3x squared, which means that y is 1/2 x squared. Now what's different about this one compared to the one we just looked at is we didn't get numbers here. We got a new relationship. We found out that we don't know where x is, but we know that y is equal to 1/2 x squared. So the question is, now what do you do with this? Well, we go back and we substitute this in to our original function. Okay, so I'm just going to go right up here. So we still have x cubed plus, now instead of y cubed, I'm going to write 1/2 x squared cubed equals 6x. Instead of y, I'm going to write 1/2 x squared, like that. Okay. So what we're trying to do here is say, okay, or we've established the relationship that a horizontal tangent will occur whenever y is equal to 1/2 x squared. Now we're going back to the original function and saying, okay, well, when does that actually going to happen? So we have to use a little bit of algebra here. We're going to have x cubed plus 1/8 x to the 6th equals 3x cubed. Okay, I'm going to subtract 1x cubed. So now I've got 1/8 x to the 6th equals 2x cubed. I'm going to multiply both sides by 8 so I can avoid that fraction. And I have x to the 6th equals 16x cubed. So now I could subtract that over. Okay. And let me kind of work up here. I'm really running out of room. Let me factor an x cubed out. I have x cubed minus 16. I want to know when that's 0. So x equals 0 is one spot, and the cube root of 16 is the other. So we can see that when x is 0, there's a horizontal tangent. The cube root of 16 is, 2 point something, and you can see, here's 1, 2, so 2 point something. This is where the other one occurs. If we wanted the y coordinates, be easy enough to find, we would simply, we know what x is, we'd substitute it back in. So 1/2 times 0 squared, 1/2 times the cube root of 16 squared.